Hello. All right. Good morning, folks. Good morning, good afternoon, good evening for the people around. So here we have for the Azure Kubernetes webinar. So today our speaker is Girish, and he is one of the leading community member, and is by profession he is a software engineer, and he is there since for a long time for the community, helping people, mentoring about anything related to Azure, especially Kubernetes. So we are glad to have Girish here on with us to describe about Azure Kubernetes Service. So yep, Girish, you can take over and walk us through Azure Kubernetes Service on today's event. All the best and looking forward to you. The stage is yours, Girish.
Okay. Thanks, Cody, and welcome to all the community members over here. So, as you know, we know about the Azure Kubernetes service getting popular. So, firstly, I introduce myself. So, I'm Girish Suri, working in a software industry around now 4 years now, and specialized in working with the Kubernetes to deploying the services, how to deploying microservices on the Kubernetes, how to handle Kubernetes in different platforms, not just in Azure, but also in AWS, GCP, etc. So yeah, I will cover up and share the experience with you regarding the Kubernetes in general, and AKS also is there. So okay, I think we should start that. So let me share my screen and just yeah. So if you can see my screen, just ping on the chat that you are able to see it, so that I can start. Thumbs up will be in the chat will be highly appreciated, so that I can know that I will be able to communicate with you guys. Is my voice? Yeah, we can see it. Okay, Cody is saying okay. So let's start with it. So Azure Kubernetes Service is the basically the offering provided by the Azure around the Kubernetes, which is basically the container orchestration. We come back to there that how we get there from the legacy applications, legacy deployment to the Kubernetes to the container world especially. So in a high level, Azure Kubernetes Service is just the offering provided by the Azure for the deploying your clusters, Kubernetes cluster on the cloud platforms, especially on Azure, and is have a now high availabilities, multi across region across clusters, and give the various tools regarding. You can see all the ports, all the namespaces, or you can configure everything out of the box with Azure APIs or infrastructure support and everything else. So yeah, so let me just put out. So these are the sections we gonna cover it, which is going back in time is basically how we get here in the Kubernetes environment from our previous deployment strategies, previously how workload is being deployed to the various we can say applications, how can deploy it when there is no Kubernetes, when there is no containers, and what problem also containers bring to us. They also bring us some problems with applications. We will discuss on that in a later part. And then we have a container orchestration part where we will discuss about how container orchestration work, what is the need of container orchestration, and absolutely then we have a why we need basically Kubernetes. What's the need of Kubernetes? Why should we already have a great solutions out there before the Kubernetes? Why specifically we need Kubernetes? And then I will walk through you to how to create a AKS, which is a short form for Azure Kubernetes Service, offering by Azure itself. And we will see how we can create a Kubernetes service in just few clicks, and you will able to just uh, deploy your application on the Kubernetes service and get delivered by the end users and whatever basically your workload. So let's begin this journey. Okay. Any questions so far? You can put it on the chat, and I can answer on that. Mm, okay, I see no questions. So let's. So here it is, going back in time. So as you see that first, what happened, like when you create an application, it's you have a developers working on that. There are highly teams, great developers out there who basically work so hard to creating your applications. So now when it's come to deploying the applications, it's get a all new another level of you can say problems, hindrances over there. How to basically deploy your application, make it highly available, which we call as now HA, so that we get never get a downtime, because we will lost customers, we will lost trust in the applications. You can heard every time that this application get downtime and they lost this millions amount of money in this just in just 4 to 5 seconds only. The applications get down and they lost lots of customer, they lost trust, they lost money, they lost data, everything. So in traditional deployment, what we have, where we have a hardware, which is basically you can say the machines we have, CPU, RAM, etc., all that stuff. And on top of that, we have an operating system, like in our systems, like in our laptops. We have hardware, then we have operating system, and then we are deploying our applications, like we did in local environment in our systems while we are developing something. Like for example, we are developing a Node.js application, so we just run it on a local host. So it's just like that. It's simple. It's basically on hardware, operating system, and their applications. Now in traditional deployment, consider your laptop will be for example basically a server. Now it's a high compute server basically, not your laptop, not like your laptop. And in that hardware operating system, maybe a Linux, Windows, whatever it is, it's depending upon your applications. You deploy various application on top of your operating systems, like one application of Node.js, one application of Java, one application of .NET. And there might be another scenario, like you have a two Node.js application, one Java, etc., and all that stuff. Now what happened in this traditional deployment is, when you create deploy new application. For example, there are two Node.js application deploying, and you are updating one Node.js application. You basically patch new dependency onto it, and the dependency which is already been there is also being used by the previous Node.js applications. So they get hampered. There's a chaos environment, because previously running Node.js application is not able to uh, understand the new function. So there's a functionality change into that, and by changing into a one application, you hampered also the second application also. And that's because they are not in an isolated environment, and they totally get hampered with each other. If one application is down, then you have to restart it manually, you have to do some automation script, something like that. You have to generate alerts, you have to do all that stuff besides the development of your application. If you are focusing on your business, you should focus on your application, not on these cases. But in traditional deployment, this is not that's why we have a famous term, like to the market, uh, time to the market. It's basically very high in the traditional deployment. It's take years to bring out a new feature in their applications. So the folks around the industry have come up with a solution. So instead of putting the isolation, they can't put the isolation over there. So what they do is the concept of virtualization. So what is virtualization is basically how we can create a multiple virtual machines inside a single hardware, you can say, or rack, you can say. So there is a hardware, you put the operating system, you put the hypervisor is basically a virtualization tool, whatever it is. It's there are various famous. Oracle is there, Hyper-V is there are multiple of them. VMware is one of the popular one. So you put it over there, and on top of that you deploy various virtual machines, which is basically a which is basically not a physical virtual machine, but a modern say in a virtual way. So that virtual machine have its own operating systems, their libraries, and on top of that you can deploy your application. So in a way we get a sort of a isolation in a single machine. Now you can deploy a particular application in a single virtual machine 1, application 2 in virtual machine 2, and so on so forth. But there's also come some hindrances over there, that for spinning up a new virtual machine, spinning up a new app, you have to deploy a new virtual machine. It has an on operating system, on libraries, on virtual NICs, everything. And that's also get hampered. It's basically spinning up time of a new virtual machine on top of a hardware is very, it's very time taken. Also there is no cluster regarding that. Like you have a physical hardware machine, and on top of that there's a limit that how many virtual machine you can create, because this totally depend on the hardware capacity of that particular rack or machine you have. So this solve the problem for being the isolation for us, but it's also come up with the new problems, like how to spin up virtual machine, how to scale up that hardware, so that we can handle all the request of the customers or the client uh, in a better way, and provide the high availability, because that if that hardware fails, everything fails, because there is a one rack or server, you can say. So now after the virtualized deployment, we come to the container deployment, as you can see. So in container, there is no hypervisor or something like that. Means is there, it's in the form of a container runtime rather than the hypervisor, because we in container world we didn't deploy new virtual machines, we deploy containers. So there's a hardware, then you have an operating system, and everything you can see that everything is done on top of operating system. The basic operating system will be there for every time for nowadays, now till now also. And then you have a container runtime. So container runtime is basically sort of a layer who basically manages your containers. So now the question arises, what is container basically? So basically, container is a sort of a streamlined, low process running on your systems, which have its own libraries, on packages, but they share a common operating system with your machine. So, like in virtual machine, we have a operating system, then libraries, and then our applications. In containers, we don't have that operating system. So spin up time, it's basically increases, because you don't need to deploy your operating system on top of any hardware or any hypervisor or any virtual layer. You just need to create your application and put the dependency into that, and and package it into it. It's called image in terms of the container world, that how you are packaging your application, and it's all dependency and package, and it's easy to deploy anywhere, and it's packaged into that, and you can deliver it and run it anywhere. It's a big hit, because let's say I created an image of Node.js application in my system. I put all the libraries, all the application code inside that, and that package is created, and that's known as image, and I give image to somebody else. It also been able to run that image in their system. Beside, there is a catch in that, you can't run Windows image into the Linux one, but that's just operating level difference. As besides that, if you are running an operating system of Linux flavor, you can run any image created by the Linux flavor operating system, as well as there is no issue of dependency, because everything inside the container. You don't need to download an additional dependency while you're copying that image from your system to your to any other system. That basically, like there's a famous example out there. Developers say that this thing is not working in my this thing is working in my system, but when I push the code to the repository and anywhere else, and somebody started running it saying it's broken, and he's saying that thing is working on my system, that issues get resolved very quickly, because all of the things are packaged under a image, and it's basically run in a runnable form now. And the instance, which is basically the runnable of that image, is known as containers. Container is just that instance which is in running format for that image. So now we got the containers. Now, as we get the containers, we get a highly available concepts out there. So we want that multiple applications to be deployed, as well as multiple instances of particular application to be deployed for HA, because if one container fails of same, there is another container to handle its request. So there are multiple containers running in our container deployment, and what we get is that there we need something like that, basically orchestrator, who can help us out that okay, this container is down, we need to spin up new container. This container is up and running, we need 3 instances of this container, we need 4 instances of its container, we need to spin up a new container. Questions like something arises with the container deployment, because every time a container get down, you hamper the performance. It's good to have containers, you get the whole image instances, is easy to run, it take no time basically to spin up the new instance of an applications, and it help us out solve various problem which we get in the traditional as well as in virtualized deployment. So anything, any questions regarding this scenario, that how we get to the container deployment from the traditional deployments? Just put on the chat. It is a package of softwares. What you're asking for? Package of software? So like image container. What is it? I didn't get the question. Can you rephrase it? R Rameshri, please. Any other questions, or should we get going?
I think we can get going, Girish. Like,
Okay.
so if
Okay.
any, yeah, if we get any other comments, yeah, somebody has another question, we can look into it.
Yeah. I got. Is Docker or Kubernetes a container runtime? Container runtime, no. Container runtime is basically how you're running your containers. Like Docker is perfect example for container runtime. Now the popular one is getting Kubernetes working with a container D basically right now. First they have Docker as a container runtime, now they have a container D. It's a popular one and it's a open source also. I will share the link after that. So it's a runtime, and on top of that there is a Kubernetes comes, so we will discuss in the next slides. Good. Okay, so let's move further. Okay, so now we got that how what is container orchestration basically. So now we get all the containers running, we get that application running in a container deployment methodology. Now what happened is when I deployed a container, so for example that container get hamper, that application get stopped for some bug, something like that. Now but I need that application to be run as 24 by 7. I need that application to be run 24/7, and I will be basically deploy new patches to sort it out problem, but that's a different thing. And now I have to spin up a new container, but that process can't be a manual, because you don't know whenever when your containers get down, you don't know whenever you get the high load workload into your applications. You need to scale it up so that every request get catered by the your applications. Like for example, you have a 2 instances working on your running on your container deployment methodology of same applications, and there are lots of requests, HTTP requests basically coming to your applications, and they are so many requests that it's degraded your instances. So you need more instances of the same applications. You can scale up easily, like you have two now, in no time you get a 4 or 6 or 8, depending upon your infrastructure limit, as well as the request you are getting from the servers. So for this scaling and restarting your application, or basically for achieving high availability, scalability, the containers are good for basically running this atomic applications. but who basically perform this activity, scalability, and restarting the containers, and distributing the traffic among the same application with the different containers. So there's come piece of a container orchestration, which is basically the Kubernetes. Kubernetes is a container orchestration. So sometimes people also ask the questions like, what is the difference between Docker versus Kubernetes? What to choose? And the answer is simple, that Docker is a container runtime. It's basically help you to create images and run containers. But Kubernetes is the thing that will basically use for how what is the life cycle should be of containers. What should be the how many instances of that container it should be there in in your servers. So I don't think so that's a valid question, that Docker versus Kubernetes, because for in the initial years when the Kubernetes come, it's built on top of Docker. If there is no Docker, then there will be no Kubernetes. But now, as we have a different container runtime, every big firm like Microsoft also hits on container runtime, I guess. And but they are basically using the container D, as I know, they are using container D as their container runtime, and on top of that they are pushing Kubernetes, which is basically also the open source one, to basically working as a container orchestration and providing other services, add-on services, or as a Azure Kubernetes services. So basically, the container orchestration is as you can see, the automatic process of managing or scheduling the workload of individual containers for application. It does not it's depend on to you that what type of architecture you have regarding the applications. It is a microservices. Yes, now you can run serverless onto the Kubernetes services. You can learn and see the databases running on the Kubernetes. I see the some guys are running ML code, machine learning, basically machine learning workloads on the Kubernetes part, to basically leverage that functionality of orchestration of and deploying the various containers, high containers, lots of 3000, I think 3000 containers running in a Kubernetes service. So it's become unmanageable sometimes, but Kubernetes helps you out to basically spin up the new containers and helping us out regarding the high availability and scalabilities of the applications. Resiliency is also one feature that to spin up to when basically a container get stop for any dependency, for any errors, and stop working. So Kubernetes is smart enough to basically spin up a new container to maintain the state which you have given, that this container should be available in the Kubernetes service for the customers and the clients too, so that they can consume it and get the high availability in terms of that. Any questions? No. So I will take it as yes. Let's continue. So now we discuss the uh, what what is basically the container orchestration. So we get an overall idea that what is container orchestration. Now, why we need Kubernetes? So Kubernetes is example of the problem which I illustrated, how to automate these things, how to manage multiple workloads, how to scale our containers. So Kubernetes is a solution of that. It's a basically the service, so you can say a package or a software which help us to create the container orchestration in our data servers on top of the any container runtime engine. And it's very flexible on that part. It's very pluggable. You can deploy your own feature, you can create your own sort of a definitions, and just able to run it on the top of Kubernetes. I can see that lots of companies also nowadays they are creating sort of operators, which is a Kubernetes term also, to basically deploy. So they just provide the configuration files to you, that okay, you can run our software in Kubernetes. Just run this command. Just run this file. That is form in a YAML. So it's become very easy also for the end companies to basically deploy their applications, deploy their piece of software to the end users, to end customer on top of a Kubernetes. So this is also they get help. So in overall, in a crux, Kubernetes, we need Kubernetes as to basically managing our workload, which is deploy on the highly scalable if we need a highly scalable system to basically managing our containers, managing our workloads, managing our microservices, all the other stuff in our workload environment. So that's why we need Kubernetes. So any questions regarding so far on part of a Kubernetes or in part of anything? Okay, I guess not. So let's move to the exciting part of the demo. So just give me a minute. Yeah. Okay. So can you see the Azure portal? Any hands up will be highly appreciated on the chat. So we'll try to create a Kubernetes service on Azure, and I will illustrate few of the steps that how easy is basically to create a Kubernetes service on Azure and how to get it there. Okay, I guess yes. Thanks, Akshay. So let us create a Kubernetes service. So something first thing first. So this is the Azure portal basically where you can manage all your you can see all services which have deployed on the Kubernetes. Sorry, on Azure cloud, and it's maybe Kubernetes, storage account, virtual machine, any other services which is offered by the Azure itself. So you can I think you can get also free credits from the Azure itself, 1500 rupees per month. I don't know, it's a student or technical one, but yeah, you will able to sign up and you get a free credits of some services to basically create a new instance of everything, and just go and try it out and it's help. So you don't have to do anything. You just go to log into the portal, just click on Kubernetes service or search over here, Kubernetes service, and just click on a create a Kubernetes cluster. So yeah, now you just have to select the subscription. The subscription is basically the logical unit that where your billing is there. So so every resource is lie under a subscription, and under subscription you can manage the costing of that particular environment, you can say. Sometimes it's basically depend on the it's uh, project company client, or the who are basically handling that project, how they are managing their cloud services. Some are using under a single subscription deploy multiple resource group, and resource group is just a logical separation of various service coupled to each other. So now you have a subscription, you can create new resource group. For example, I will create AKS demo Azure RG. So let me know. And this is a new thing offered by the Kubernetes AKS. Basically, this is cluster persistent configuration. You can use on top of how frequently your cluster will be. Basically, how this what is the main purpose of creating this cluster. So you can use dev test basically for testing environment of your testing environment of your applications. Standard is also there, cost optimization, batch processing, harden access. It's basically depend upon what are you are deploying on this cluster. So for now, I'm just picking up the standard as is recommended one if you don't know what workload you are deploying into it. So now we have a Kubernetes cluster name. It is basically the cluster name of the Kubernetes. Let us put it AKS demo. It's a region, basically which region you are able to you want to deploy your Kubernetes service. So I'm deploying on West US, and so there are no availability zones after that. So the availability zones are basically data zones in a particular region. For example, we have a West US, there is a data center, and under that data center, you have a multiple zones. So it's saying that no availability zones for this location you have selected. We can select that, but it's if we are creating a production ready Kubernetes cluster, you can. It's highly recommended that you should use availability zones when you're creating it, because it's help us to also create a hardware level sort of a high availability zone for you. Now the node side basically is a virtual machine size. which you needed, that what type of a virtual machine you need to deploy on the Kubernetes cluster, because Kubernetes cluster is just a bunch of virtual machines which are connected to the through each other, and deploying on top of that we are deploying the containers. So you can use the any container, any virtual machine you needed on the, it's basically depend upon the what code, what sort of application you are deploying onto that. Now, as we talk scaling method, so there are two type of a scale method: is a manual and auto scale. This scale method is not on a container scaling. This is a scaling of nodes. Nodes means virtual machines. How can you downsize and increase the size of the virtual machines, number of instances, number of virtual machines to be there in a cluster? So there would be a manual option also there, that okay, I need one, I have a three, and then I can have an auto scale that for one, and if there any container need more space, then I can spin up more virtual machines. Okay, so there's a question. When we're deploying our services to AKS, then internally all of these container services run on Docker. Uh, no, basically means in a time previously it's run on Docker. Container runtime is on Docker, but now I think every major vendor, like not just Azure, AWS, anybody, is moved to the container D. So container D is the basic unit where you can run the containers. So now everybody's moved that. So it's basically that you can run your containers, you can create on the container D. But container D has it's a lots of problem to creating the image, but it doesn't matter. But it's a one more thing that when you create your Docker image, it's runnable to every other instances, whether they are using Docker or not, either it's a container D or anything else, because everything is made up of now the specification of OCI, which is a open container interface, something like that. So everything is made on top of that. This is like in authorization authentication we have OAuth and OIDC. It's basically a standard for every identity service to basically become standardized, so that any other identity service also can communicate with them. It's something like that in that world, that we have OCI. So every containerization runtime is basically built with the specification provided by the OCI. This answer your question, Gaurav? Okay, and Akshay saying three data center within the same location. No, three availability zone with the same location, like West US. Then under a West US, sort of imagine a warehouse, big warehouse, and in warehouse we have a different, you can say rows, and that rows are basically the availability zones. Okay. Now where we have, yeah. So we are talking about the scaling method, how to scale our Kubernetes services, and cluster. So we can have a two method for it: manual and auto scale. So in manual you can just add the numbers, that okay, now it's one. We like if I have a need, like for example, for a testing environment you don't need very virtual machines, it's hamper your costing. You can have a one, but if you are testing something at that time, you can manually increase it to three, four, something like that. And auto scale is basically recommended for the production level environment, that minimum you have, for example, five, and you can scale up to eight. So it's depend upon the workload which you are deploying on the Kubernetes. On that, it's basically scale up your cluster size. For example, I'm using the manual one. I don't want to more, and I'm just using two node counts. Again, it's the node pool. So this is basically the fun part. Node pools, this is offered by the AKS. This is not a native feature of the Kubernetes services. So node pools are basically, you can have one node pool of a different size of a machine, and another node pool of a different size of machine, and you specify that okay, on the bigger size, which have a bigger virtual machines have in the capacity of CPU and RAM, you deploy, for example, machine learning code. So you can also do that, and you create, and on the other part, like we have using standard B2S, which is a low configuration virtual machine, you can deploy your web applications. So you can basically fragment these into parts in the node pools, and so it's make easier as a deployment, so that we can say that okay, this workload need to go to the standard V2S, or this container is to go to the, for example, D2S, another virtual machine offering by that. So you can add that notables over there. Another one is virtual node. Virtual node is basically the quick virtual nodes, basically like you, for example, you get a various requests at a time, and you need new virtual machines so that you can accommodate new containers which is creating by the Kubernetes. So you can enable virtual node is basically spin up very fastly the new virtual machine to your cluster, and get the containers deployed on to top of that. Encryption type is basically another thing, that how you want to encrypt your virtual machines which are part of a cluster. These all offerings, these all things which I'm now discussing is a part of offered by the AKS. Like if you have a native Kubernetes cluster, you build it on, like you bring three virtual machines together, you connect it through a network. You have to do all that stuff to yourself, that you have to manage that. Okay, how can I add a new virtual machine, that you have to bring a new hardware, something like that. You have to connect it, you have to put the DNS in between them so that they can communicate with each other, all that stuff. But if you are using AKS, Azure Kubernetes Service, this is out of the box provided by the AKS to you. You just need to provide the configuration. Okay, I need this, I need this, I need this, and it will create that instance for you so that you can deploy your applications on top of that. Now again, another is access. So who can basically access your Kubernetes cluster? Who basically sort of a deployment manager, you can say, and who can access, like a person in a team can access a whole cluster. He have a whole flexibility to basically go inside the cluster, create resources, delete resources. Some of have just a requirement of they can just only read the logs of the container, something like that. So you can use this feature for that. You can ask RBAC role, which is a popular one, standard nowadays, basically role-based access control. According to role, provide the permissions to the user, or you can use the AKS manage Azure Active Directory. That's a cool feature. That's a very cool feature. Like you have an organization where you have a users is already onboarded on that. You know which users are access to your team. So you create a group, you put all the users which you want to access that Kubernetes cluster, and then you just enable that. Okay, this group can access our Azure Active Directory, and under that group there are multiple users. So every user can add. So you don't have to manually add every user to AKS. So if for example, we have four people working on that, so we created a group and we add four people and that into that group, and then provide access to admin as Azure AD group. And if one person is leaved, then we just kick out that person from that group, and is no longer able to access the Kubernetes cluster for us. And yeah, next part is networking. So like I said, that if you have to configure the networking. If you're deploying your Kubernetes cluster, you have to deploy a plugin which is Calico, Fennel. There are Canal. There are multiple plugins, virtual plugins, which gives you a functionality to basically connecting the virtual nodes, how the traffic going on the virtual containers. So Kubernetes provide us Kubernetes, which is the native one, I guess, and the Azure CNI, which is provided by the Azure itself. So if you are using Azure CNI, you can put out the virtual network if you have one. That okay, I need this Kubernetes cluster part of this virtual network, and this is the cluster subnet, basically the subnet which in which the Kubernetes cluster reside. Then you have a Kubernetes service address range. So in Kubernetes, we have a terminology like services and deployment. So services is basically a load balancers, which sit on top of your application. So as I said, that there are multiple instances of the same applications. So you need to divide the workload into between them. So you will do that by the services. So services get the IP, and you hit the service, and service eventually hit your applications. So here you can also provide the address range for the services, that okay, so if new service is created, this should be the IP address for that. Docker bridge is another one for that, that how the Docker is basically connected with each others on that part, because inside that we are running the Docker images and all that stuff. Docker is running on that. So you can also provide the IP address ranges for what will be the Docker bridge added, what will be the DNS name prefix. But if you don't know what to do, you can use the Kubernetes by default one. That's also help out, because we use a minimum, some site minimum Kubernetes cluster. For using this one Azure CNI, you need lots of information. For example, because in a bigger organization, you have certain rules you have to follow. You have that, okay, this subnet is for reserved for the Kubernetes. You have to give that IP address. You have to give this CIDR to basically deploying it. And another things we have is traffic routing, and enable HTTP application routing. So now you, let's imagine that your Kubernetes cluster have deploying the multiple application which are in microservice architecture. Now you want to expose their APIs to the outside world. So you have to expose every API, every application, every services to the outside world. That basically gives every service a new IP address. Then you have to recommend, then you have to know that this service IP for order is different, for products is different, for anybody is different. So you can use a single entry point for your applications, and then that entry point is basically distribute that, okay, it's want to go on the order service, let's go there. If you want to go to product service, then go there. So this enable HTTP application routing helps you that it's deploy another service on top of the services, which is popularly known as, you heard it, ingress controller sometimes. So now we have to deploy it manually before that. Now Azure is basically providing this for us. So that's a great feature also out there. Another one is security. So you can enable private cluster. This is basically that your cluster is whole private. It can't connect to the outside world. You can't access it outside the world in terms of managing it. And yeah, that's it for the private cluster. And then we have a set authorized IP ranges. You can allocate that, okay, these IP ranges only can access my Kubernetes cluster. So this thing you have to, if you are doing on-prem or creating your manually Kubernetes cluster, you have to do these things by applying the firewalls, by applying the DNS and managing all that stuff. But with AKS, this is providing out of the box. Another thing is, you can put network policies over there. Network policies is how your Kubernetes, inside your Kubernetes cluster, how the containers which are running on Kubernetes can connect to different sources. Can they talk to each other? Can they talk to the outside? Can they talk to the different namespaces? Namespaces is just a logical separation of containers, where we can deploy the multiple containers, and you can basically create a boundary between them. Okay, two namespaces can't connect to each other, can't talk to each other if they are services in a same Kubernetes cluster. So that is the network policy. And you can enable Calico, and it's help us providing a YAML configuration sort of a format to basically enable the network policies. Then we have integrations. Integration is basically that how, where as I say, the Kubernetes deploy application on containers, on which is known as pods in Kubernetes. So you need a registry. Container registry is basically just where all the images of your workload is being resides. So you just don't put your application on Docker Hub, which is an open platform. You have to create your own registry to safeguard your images. So you can create on your container registries and put all the images on that, and Kubernetes cluster just fetch the image from there and able to run it. I'm just using none. And container monitoring is basically Kubernetes provide, or AKS also provide us that you can monitor your whole cluster, that what's going on. Okay, we have spin up a new container, new application is deployed, this instances get wrong, all of that logs. So you can also enabling the container monitoring on that part. Again, we have a Azure policy, which is a native feature by the Azure. So it's now go through also to the Kubernetes, that we have a predefined policies, and you can create custom policies, which you can enable and disable, and you can just follow the standard for that. See, now we have, I think, advanced. tags, which are all basically the Azure infrastructure things. And this is how you can create the Kubernetes cluster. And it will take time if I create it. So I already created a new one. I created this one yesterday for this demo. So when this basically Kubernetes cluster create, it's look like this. You have a namespaces. You can see the namespaces. What are the namespaces available to you on that Kubernetes service? You can see default. Default is the basically where if you didn't mention any namespace, all the applications will be deployed on the default one. These are the namespaces used by the Kubernetes cells. Kube system is the popular one. You can see labels provided, that creation time, status, all other stuffs. You can also find workloads. Workloads is basically your application containers which are deploying onto that. You can find core DNS, autoscaler, matrix server, AKS links. These are the deployments, and these are the pods which is deployed on the your Kubernetes cluster, which are basically the workload, atomic workload you have to deploy. Replica set, stateful set, jobs, cron jobs, everything. You can find everything from that. For if you're deploying on-prem, you have to deploy something else to get this sort of a portal where you can all see that, okay, this services exist in my system or not, or something like that. Now you got services. Services is basically which sit on top of your pods. So you can see the Kubernetes service, kube DNS, and metric servers. Kubernetes service is basically the service through which you can access the Kubernetes cluster. Storage is also there. There is no storage right now, but you can also create from here also. And configuration. So configuration are basically that how many have you have a config maps, secrets present in your Kubernetes cluster. Config maps are just a sort of a information, JSON file, CML file sometimes you need for deploying your applications. That information get changed, and you can basically connect those information config maps to your pod, so that every time you change the config map, pod also get changed, so you don't have to go inside the pods and make changes. So it's basically solve out that problem. So you can see all of them are also there. They are certificate you can store into that. There are also various secrets and node pools, as you suggested that we have only have one node pool, that you can deploy multiple node pools. And in a single node pools they have a multiple nodes, so we have only one node. Now we have a cluster configurations, what sort of a Kubernetes version we are using, what we are using for API server availability. This is 99.95, it's a great SLA provided by the Azure itself. Networking, that which pod or CIDR we have. So every time a pod new created, basically the container new created, you can say this, they get the IP from this IP address range 10 dot, which is provided by you itself. Open service mesh, it's a new thing also come with, nowadays we are using service mesh to basically deploying those services. Can you see my screen? I lost my screen. Okay, now I get it back. So basically the service mesh is a sort of a tool nowadays everybody using in top of Kubernetes to basically see what's going inside my Kubernetes cluster. It's get everything out of the box. It get the logs, that okay, this application is hit by this, this container is down. You can manage your deployment also, like canary deployment, blue green deployment, everything. uh, GitOps, it's on preview. Deployment Center is also in preview, and the policies, as we talked about Azure policies, you can create your policies and to make your Kubernetes cluster well standardized and more less prone to the any security hack and security bugs, any vulnerabilities. So yeah, I think yeah, we just covered it everything as part of a Kubernetes cluster, and you can natively access your Kubernetes cluster with the kubectl command. So if I go to this overview, and I can connect with my Kubernetes cluster, so it gets the uh, gets all the command I need. I need to just set the subscription, get the credentials, and then natively you use kubectl commands for any Kubernetes cluster. You can just go with it. So I already done that, and if let me increase my size, you can see kubectl get pods all namespace. You can run this command and you can get the as you can get the native Kubernetes cluster deploying on any other part on AWS, AKS, on-prem, GCP, DigitalOcean. Never mind. So kubectl basically works on all top of that. It's not that we have another. We need to learn another CLI or another tool to basically access the AKS cluster. You can use the native one, kubectl. So I think yeah, I covered it. Any questions? Okay, there is a question. Is RBAC and ADD work same? ADD means you are talking about Azure Active Directory or anything else? ADD, didn't get that. Sham Krishan, can you rephrase the question? Any other question will also, I will take the question now. So you can put the questions. Active Directory. Okay. So basically, Active Directory is is basically the implementation so that you can use RBAC also. So in Active Directory, you have user. User is a part of a groups, and RBAC is using that groups to basically getting authorized to access some resources. So you can't say that they work against each other. For working in a RBAC, you need some sort of a identity provider. In our case, this is Azure Active Directory. How to troubleshoot the pods in Kubernetes cluster? Okay, it's depend basically on what does problem you are solving. So the first thing I think you should look into the logs. Like let me get pods. These are the run by there. So kubectl logs, I think pod name, and I have to specify the namespace, which is kube system. So I think first thing you have to run this command to basically get the logs so that you know that what's get wrong with your Kubernetes cluster. In general terms, I'm not talking about the AKS or something like that. Or in AKS, you can go to the application inside and check it out that okay, is there any logs which provide us the information that what's go wrong with my pod, and then you start troubleshooting. It's basically an incremental process. Then you know okay, there is no things like that, there might be issue with some networking. There's a lots of scenarios, so you should start looking with the logs. uh, it's my suggestion that you should go with the logs and then increment your troubleshooting techniques. Go for the networking, go for the instances why it's getting uh, means showing error, something like that. It's your application which is showing the error, or it's pod which is failing, or the Kubernetes cluster. So these are the questions you should ask before troubleshooting the pods. Yeah. Any other question?
Guys, if you have any questions, please feel free to ask, or else, well, we have 5 minutes
Yeah.
for.
Okay. Um, can you share some resources that we can go through? I think you can go through the Kubernetes. Let me open that. Kubernetes Docs is basically the, I guess, goodest entry point. I put it on that, and yeah, also you can. That's a great place to start. Landscape.cncf.io. It is basically the cloud native foundation, which is sort of maintaining all the open source tool as well as some proprietary solutions. You can find Kubernetes as part of that. Here it is Kubernetes. So you can also find lot of tools which help you build your applications and able to deploy on Kubernetes. For example, service proxies there, API gateway, service mesh. So you can find lots of example that we have a Linkerd service mesh over there. So let I also put this link to you. It's great point to start because it's some mostly are they are open source and they are sponsored by I think every major company. Microsoft is also the part of this Azure, like basically Microsoft Azure. Yeah, I think this will be a great links. And yeah,
Any
anyways,
more questions from anyone?
any
Uh,
questions?
we have one
Is
question coming from Ramakrishna.
Yeah, yeah. Is Kubernetes commands are similar in AWS? Yeah, exactly. That's what I told. That kubectl command work for every Kubernetes cluster you have. It's not that where you deploy it. It's work on on-prem GCP, AWS, AKS. You just need a kubectl, and you just need a kubeconfig file basically, which is the basically the credential file through which you can access it, and you good to go.
Like whatever Girish mentioned, that reference links were there in comments. You can go through it. Uh, any more questions?
Can we integrate Azure API Gateway to AKS cluster? Yes, you can. Actually, there is a whole guide for, I guess, if I'm not wrong, Dockers, Azure, Kubernetes. You are saying Azure API management, right? So I think there is a whole docs regarding that. You can use Azure API management. Yeah, this is the link for you, I guess, if you want to see. You can do that. You can also do that. So it's a whole defining whole process, background, that how should you deploy. It's example that this is your API management, this is your virtual network, this is your AKS, and you are deploying. You are just leveraging the Kubernetes from API. Okay, can you please explain engine ingress in AKS, how it works, and how can I implement it? Oh, that's a that's a big thing to ask, but I will try it explaining it. That basically nginx ingress is basically the entry point. For example, you have a multiple services running. uh, let's In this diagram you can see there is a service A and service B. So you have to expose both the service to the outside world to consume it. So instead of doing that, you can do, you can put a ingress controller over there, and that ingress controller is basically exposing a service as a service. So now you just hit the ingress controller, and on the basis of routing, host name, the ingress controller will decide, okay, this route belongs to service A, so go to service A. This route goes to service B, then go to service B. So there are a whole lots of implementation to implement nginx ingress in Kubernetes, and you can find the YAML based configurations. So you can point out, okay, if I got slash orders, then go for the order service, something like that. So there is a great link also there. Let me find it. I think yeah, this is also a great one, which helps you to start with that Nginx on Kubernetes cluster. So you can put the YAML configuration to basically decide that, okay, what sort of applications will be routed on what basis, on a host basis, on route basis. And you can use ingress controller some sort of a proxy, so that if you add slash API, and after that whatever it is, it matches on that basis and go to that service which is belong to. You can also use that. So it's a great link to start, I guess. But you can find also the nginx alternative on this. Let me see, is there? Yeah, Envoy is getting too much popular nowadays, service proxy. So you can also use this one. Any other questions? I know. Okay. or should we wind up?
Yes. Okay.
Okay.
Yeah,
Okay.
we'll wind up session at this moment. So yeah, just to quote with you guys, like Girish is a go-to person for any cloud-related things, especially Azure services. That you can reach out to him and you can get it mentorship with him. So he's very go-to person. He'll clear all your doubts. So thank you so much for the wonderful session, Girish. Really, it is very insightful. From the beginning, why to start Kubernetes to wonderful demo, and we have come across various things from the beginner level. And look, like me, all the people have a proper understanding on the things, I guess. So yeah, we're good to go, and looking forward to hear all the people feedback. And thank you so much for the session, Girish, once again.
Yeah, yeah. Thanks for this opportunity, Varun and Koti. It's really helpful, and I think I can add some more information on your box, and we will connect on later part. Okay, I got a new question now. Can we use our own monitoring tool to monitor Kubernetes pods? Yes, you can, and it's also getting standardized nowadays. You can search for open telemetry, and it's a great tool to start with it. There are multiple options also there. Okay, over to you, Koti. I guess.
Yeah, thank you. Yeah, thank you so much for all the audience for your wonderful participation. And once again, thank you so much, Girish, for your contribution to the community, like every time. Uh, thank you all.
Thank
We'll
you.
definitely in touch. Thank you.
Thank you.